What you're going to hear about today is nothing short of a miracle. It's dramatically new. It's an RCA Victor exclusive, made possible only through years of research.
Hey everybody, welcome to the Tone Church. I am your host, the Abbot of Tone, the Monk of Music, the Cardinal of something. Cardinal of bad puns, I guess. We'll work on that one. Anyway, I'll be your host, an eccentric recluse that likes playing with high voltage.
Well, what would you say it takes to be a do-it-yourself hi-fi enthusiast like yourself? Oh, doesn't take much. Only money, a thorough knowledge of electronics, a lot of spare time. Your wife threatens to leave you. But if you want real hi-fi, well...
Very special episode today. A little quick little background first here. The Tone Princess is a music lover, and she has a very respectable collection of LP vinyl albums. And she's been using a modern kind of setup where it's an all-in-one. It's got the record player and CD player and everything all in one, but it looks like it's made out of wood. But, you know, probably made in China, and I'm sure if we look under the hood, what we're going to find is...
Every component of this set is the finest hi-fi equipment made.
Probably substandard. So, no self-respecting audiophile would be playing their records on that thing, so...
Once you've heard high-fidelity reproduction, you'll be hard to satisfy with anything less.
What are we going to do? I think we all know what we're going to do.
You get a powerful radio with the rich Golden Throat tone system. It costs as little as $39.95 in maroon.
What we did is we went on Reverb and we found a great deal. We found a chassis pull from a 1960 RCA console. Console itself was a model PVC 244. Let's see if I can find a picture and throw that on here. And that sucker must have really kicked out the jams. It had its 3 outputs. So it's got left, right, and a center bass channel. So Dolby 2.1 in 1960. Who knew? And yeah, like I was saying, that thing must really kick out the jams. The center bass channel had a 15-inch Jensen speaker. But unfortunately, the console itself is lost to the sands of time. But we do have the chassis, and it's an RCA 189B. Alright, so let me flip the camera around, and we'll take a look at what we got and what we're going to do. Alright, if that all sounds interesting to you, and I'm not sure why it would, but if it does...
Hi-fi? Why, sure, you bet. Certainly I can tell you what hi-fi is.
Hang tight, here we go. Alright, here is our 1960 RCA 189 Bravo chassis. Let me get Mr. Pointer here. Pretty cool stuff. We got a very healthy looking RCA power transformer. The code on that is 138031, so 31st week of 1960. 138, I'm going to assume it's RCA, but we can double check that, the manufacturer code. And then we have left and right single-ended output transformers. And then this beefy one here is for the center bass channel.
For more music power.
And this runs on each output transformer gets its own EL84/6BQ5. They will be called 6BQ5s from here on in because we live in America. Fuck yeah! And then what else has it got? Each channel also has its own preamp tube, which are 6 CG7s. And then we have an extra 6 CG7 here as well, which I believe goes to the bass channel and gives it a little more beef. Alright, so can you see all that? Here's what all that looks like. And I got this on Reverb for a grand total of $89. Right? That's what I'm talking about. Can you see that? Is that centered? Got a couple of can caps. It's a little weird how they use these. Each can cap has 4 sections. And let me see if I can read this. The first one has 2 35s and 2 20. microfarad sections, and then this guy here has 4 20 microfarad sections. And they're using 2 sections from this guy, the 235s, and then 2 sections from this guy, 220s, as your filtering capacitors. But then they're also using 2 sections from this guy and 2 sections from this guy as cathode bypass caps, which is odd. I don't know why they just went through all the filtering on this one and then all the bypassing on this one, but they did what they did.
RCA, first in recorded sound.
All right, so what also made this an awesome deal is it came with all of the original RCA tubes.
So be sure you insist on genuine RCA receiving tubes.
Check them out. You see that? Look at that. Nice. 43rd week of 1960, and they all have the same date codes. Nice, nice. We have this, we got 3, the 4th 6CG7. Is that what they are? Is that what we said they were? Yeah, the 4th 6CG7 is in Oscar the Grouch's can.
I live in a fucking trash can with some whack friends, keep banging Mac 10s.
And does this come from the factory like that? Because there ain't no way you're getting that sucker off. And that's for the 2nd stage in the bass channel, I believe. Which is odd. You would think you'd want the 1st stage to have the shielding, but whatever, here we are. And then finally we have our 3 6BQ5s. Looking very nice, can you see that? And one of these is, it's got a little bit of toastiness to it. So I'm assuming that was for the bass channel. It's probably, you know, kicking out some jammage. I put all these tubes on my tester, and they all test like new, except for one of the 6BQ5s, which has internal shorts. So unfortunately, we'll have to break up the band and buy a replacement drummer here. Another odd thing I found was 2 of these power tubes are black plate and 1 is a gray plate. So I'm not sure what the deal is with that, but it looks like they were using the gray plate in the bass section for the bass transformer, bass channel power transformer, you know what I mean. But I figured this guy, if any of them were going to be weak, it would be this guy, but this guy actually tests the best. But it is what it is. What else we got? We got some knobs. Actually, we got this thing. Got the control panel. Looking very vintage. And we got some knobs. And they kind of all look like this. And kind of wanted to replace these because, I don't know, I'm just not enamored with this look. But I don't know if we'll be able to find replacements to fit on those shafts. They kind of like, what is that, 1/4 inch or even 3/8, I don't know, 1/4 inch split shaft. But we'll do some digging around on the internet, see what we can find. But we may just end up using these. Because I was looking at stuff online, and I think we want the final end product to, you know, be like a steampunk theme thing. With like a copper, sheet of copper, sheet metal on top here. With a nice wooden enclosure. But we're a long way from that. Alright, so that's what we're doing here. Let me put these tubes away. And yeah, we're a little bit out of our wheelhouse here.
And do you think you can tell us what hi-fi is? Oh, yes. Yes, of course.
Normally we do guitar amplifiers, so this is all new to me. So we will definitely be learning a lot. Let's take a look at the insides. Oh yeah, you see all that?
Any questions?
That is hand-wired point-to-point goodness right there. Definitely gonna have to shock on all the caps. These are all old wax caps and they're all bubbling crude. Another thing I liked is the way they did this bus bar. You know, they got it connected on 2 ends, and then, you know, all your grounds are nicely routed into this bus bar. I think I'm going to use this technique on, you know, the builds that I do in the future. You can very easily control the path to ground for all your stuff. A couple of big caps up here. But I did some probing around. Everything looks good. The transformers all have continuity, primaries and secondaries. Pots all look good. Everything looks good. I don't see any major problems other than, you know, the caps needing to be replaced, and then, you know, trying to reroute these wires. We're going to install some, you know, nice modern RCA connectors, because right now they're using, you know, their own.
RCA Victor's non-breakable impact case means no chipping, no cracking.
Oops. Well, it was good until we just broke it. These kind of connectors for your inputs. So we'll replace those with RCAs. These are the speaker wires, go directly to the speakers, so those will be replaced with banana plugs or something like that. That's the plan anyway. So, yeah, that's what we're doing. Alright, let's take a look at the schematic. Alright, here is our schematic. Comes in, and then we have a couple of terminals to like plug in our record player, stuff like that. Our other components. It does something weird here with these caps and this switch. Not exactly sure what's going on there, but we'll figure it out. And then pretty standard stuff on our secondary. We have a couple of brown wires, a brown and a brown black, that are used for our heaters. And then several stages of B+. Simple stuff. And then these are those 3 sockets on the side I just showed you that goes to the big chunky switch, so you can select which component you want to use. And yeah, real basic stuff. Got the left channel, the right channel, and then a mono center base channel. But we'll get more into this as we go along. We'll see if we can't backwards engineer this, but looks pretty much like a guitar amp. One thing I noticed, there's no grid stoppers going into V1 here, so that's a little different. I don't know if we should add some. I don't think we're going to reinvent the wheel. I think we're just going to, you know, when we service this, we'll just make it to the print.
Joe calls RCA Service Company. Skilled RCA service for fine RCA Victor television.
Get it up and running, and then if we need to, we'll start tinkering. We'll do some research and see if we can't find some good mods that would make this even better. It also has a bunch of those
this network right here, and this is what's called the tone sucking network.
Packets, those square packets in the tone stack, like you see in mid-1960s Gibson amplifiers. Hopefully those are all working good, but if not, we can you know, reconstruct this with discrete components. Shouldn't be an issue. Had a plug for a reverberation unit right here. Not sure what that is, but it sounds awesome.
New RCA reverberation sound system for concert hall realism.
But we won't be using that. So there is a plug that we're just going to it's going to plug into itself instead of going out to the reverberation unit. So it's just going to pass on through. And yeah, basic stuff. All right, let the adventure begin. Oh yeah, you wish you had one of those. We also have the record player. How cool is that? Don't know if it works. I've never done any kind of electrical work on record players, but this will be a project for another video. Hopefully I did not destroy the needle when I carried this home from my day job where I had the whole thing delivered. But yeah, something to look forward to. RCA, baby.
By RCA. First in recorded sound.
Doesn't that look nice? Wish I was there. For the record, here is the parts list. More parts.
I'm a parts man. Of course, stupid of me.
Alright. So the first thing we want to do is see if we can't understand how the amplifier works and match up everything from the schematic to the actual components. We'll label the schematic. We'll figure out what all the wires do. We'll label our schematic so we can remember how to put it back together. But we're going to want to get these guys out of the way so I can see what's going on underneath. And that's your first stage of filtering. That's these two guys right here. 200 microfarad capacitors in series. And they're connected to our rectifying diodes, which are these guys here and here. And I tested these and they're still dioding. So we're not going to change those right now. One thing I noticed here, which we'll probably address, you probably can't even see it because it's so skinny, is a fuse wire right here. I think it's a 1/2 amp rated, but it's a teeny tiny fuse wire. So we'll probably put an inline fuse holder somewhere or just bridge it. I think it's for the B+, you know. I think that's overkill. But we'll get to that when we get to that. Alright, let's start tearing our guts out. We pulled the two 100 microfarad filter caps out of the chassis. Got it on the meter here. This guy here, reading about 114, so 14% out of tolerance. And this guy was reading like 143, so she was way out. I don't know why they're different styles. Both 100 micros, but you know, the top one has a different color and size package and whatever, and this guy's completely coated in melted wax, so I don't know, maybe the wax preserved it a little bit better, but alright, they're out, gonna be replaced. Now we have an unobstructed view of all the stuff underneath. So now we're gonna carefully trace out this circuit and write down all the color codes on our schematic, so hopefully we can put this back together the way it's supposed to be. Alright, so I'm trying to figure out what they have going on here. This first pot, it's a push-pull, and then turn is for the volume. And it says pull, normal operation, push, phono automatic off. But let's call this top guy here hot. So come out of the wall, and then we have a path to the switch. Close the switch, and it goes through this way to the power transformer, but it also sends 120 through this 0.047 cap to the record player plug. That's this guy here. We have another receptacle plug, and then we have the plug for the reverberation unit. But anyway, so close the switch. It's got a straight path, and it's also got a path through this capacitor, and the same up here. So we can either go this way or we can go this way to go through the switch. So it's like they have these capacitors wired in series with the circuit and also parallel. Does that make sense? Because it's, I don't know, I don't understand what these capacitors are supposed to do. I'm sure it's standard everyday practice in this kind of thing, but I just haven't, you know, inserted that knowledge into my brain just yet. But we're not going to reinvent the wheel. We'll just replace these and carry on, because everything seems to work. Hooked up a meter when I pull the pot, get continuity through the power transformer and everywhere it should be. So we'll just replace these. When we're working with AC, you know, we want nice, new, reliable capacitors so we don't electrocute anyone. We're also going to add a 3-prong power cord. I know all you hi-fi people just started yelling at the screen, "The hum! The hum!" Well, I'm less concerned about hum and ground loops than I am about electrocuting the Tone Princess. So we are going to add a 3-prong power cord, and we'll deal with any extraneous noise as it arises. Alright, moving on. Another thing that we are going to do is add a fuse to the mains, probably right there. This guy doesn't have a fuse other than that one that's in the B+ area. So yeah, safety third. Fuse. So looking at this setup a little bit more, we see we have a double pole single throw switch, and one side, the two poles are bonded together. If we look at our switch, the two poles here are bonded together. And I got to imagine these capacitors have something to do with trying to eliminate line noise. But we also have the, in the push mode, phono automatic off. So maybe when we get to the end of a record, somehow with this setup, the play arm goes back to the home position and shuts her down. Don't know. Pretty neat though. Alright, so we're working on replacing these 2.047s on the main side. And this leg was removed from the, we'll say the far half of the double pole single throw switch. So just imagine this guy is plugged in over here. And then, put some light on here so you can see what's going on. It's really tough to see. So we have both capacitors connected at, we'll say, the bottom common end of the switch. And then, again, this other end of this capacitor goes to the bridge negative side, and then the other end of this capacitor goes to the other pole. The other, we'll say, the top common pole. So pretty easy to replace once you get all this dug out. And as you can see, modern technology has definitely brought some advancements in capacitor size and design. Alright, we have our 2.047 microfarad capacitors soldered into the on-off switch here. We added this wire here. The AC, we're going to call the hot side of the AC power plug, went directly to this pole over here. And since we're adding a fuse holder and a fuse, this wire will go to the tail end of the fuse holder. But so that guy's there, everything's all wired up, and we're just making sure that it functions the way it should. We have the negative lead of our multimeter in continuity mode on that on the far side of the switch, the two poles that are soldered together. And the way it worked before, on one of the poles, when the switch is pulled out, there would be continuity, and then there would be continuity on the other pole when the switch is pushed in. So let's do that. Okay, so confirm that the multimeter is in continuity mode. Switch is pushed in. We got nothing on the bottom pole. And we have continuity on the top pole. Pull the switch, that goes away. And on the bottom, here we go. So hopefully we didn't screw it up. And these wires here, all the wires here, I clipped the tips off and resoldered them with nice fresh pieces of the leads, because it looks like at the factory when they got in there with their soldering iron, you know, some of the insulation got melted a little bit. And it was a little bit sloppy. Not real bad, but just, you know, we did it a little bit better.
Call RCA Factory Service.
So that's done. Time to move on. I'm about to drill a hole into the chassis for the fuse holder, and for posterity's sake, we want to record these this information here, because I'm going to drill a hole right here. So Rs-189B is the chassis, and then RVG274041. Not sure what that is. It's a manufacturer code and a date code for something. 274 being the manufacturer code, and 41st week of 1960. But we'll look into that a little bit later, but there's about to be a fuse holder put right here. Before I forget, and while I'm looking at it here, when the gentleman I purchased this chassis from pulled it from the console, he cut these wires here, and it took a second for me to figure out what they were. These are heater wires that are going to the indicator lamp that was probably mounted somewhere on the console cabinet or wherever, control panel somewhere. So we can just tap into these, and we're gonna have to figure out somewhere to put an indicator lamp. gonna have to think about that because I gotta kind of imagine the what this thing's gonna look like in its final configuration. We could just stick it on top. We might have enough room here to stick the lamp holder, or we may integrate the indicator lamp into the cabinet that we build for it. But I'm gonna think about that. I'm looking at this bus bar here. It's not connected to the chassis on this terminal strip. So we get all our grounds. Goes over to here, connected to this lug, but it's actually bonded to the chassis through this wire right here. And everything, all the grounds flow along this line, end up right here at the chassis. That's your chassis ground. I really like this. I bet you this is really quiet. Or not, it might be super noisy, but we're going to find out, hopefully. But I really like this. We got it connected, you know, nice strong connections on both ends, so it's sturdy. And then we very methodically control the flow of electrons, or the reverse flow, I don't know, depending upon what system you want to think of this in. But it all ends up here, ends out right there. Cool stuff. I don't know what brought that up, but anyway, we're starting over here at these capacitors and trying to figure out what these two do, and once I understand what they do, we're going to replace them. Got another cut line here. This must have had something to do with you know, other equipment in the console, hopefully. But we'll get him out of there so he's not dangling around. Alright, back at it. Alright, this guy here is a 20 microfarad cathode bypass cap for the second preamp tube in the center channel. So it's going to pin 8. Let's see here, V14. Where are we here? V14, pin 8, and he's right here, 20 microfarads. He's a big chunky one. So that's what that guy is. It was hard to see. I thought he might be going to the center channel power tube, but he's not. And now we just got to figure out what this guy is. And for reference, this is what we're looking at. Alright, we got that cathode bypass cap out of the way here. And this guy here, for reference, this is where we're at. That is, where are we here? Okay, so that is, let's get some light over here. That is the 0.27 coupling cap, which comes off of the plate of the previous preamp tube. It connects to the grid of the power tube for the center channel. And we should have a 470K grid leak connected to this pin as well. And if we look, if we can see, look down in here, and connected to that same pin. We can't see it. We can't see it. Uh-oh. Oh, we're a mess. If we look right here, this guy right here, connected to pin 2, and the other side of the ground is our 470K grid leak. Alright, glad we got to the bottom of that. Here's the cathode bypass capacitor for the second preamp tube of the base channel. And it's supposed to be a 20, and we're at 33. And then these other two capacitors that we replaced, they were way out as well. They were like 40% out of tolerance. So, yep, shotgunning was the right decision to do on this amp, it seems. So, we've got this coupling cap here. That one there in highlight in yellow, or highlighted. It's just absolutely disgusting.
None of that messy do-it-yourself stuff for me.
Covered in sticky wax. And it's supposed to be 270 nano. So we're about a 300% over. It has drifted. But also, check this out. Boom. Yeah, that's not good in a coupling capacitor. So, yep. Just another indication that shotgunning was the right thing to do. While we are in this area, we can see this resistor right here looks really cooked. And that is this guy right here, this 120 ohm cathode bias resistor. And I measured it in the circuit, and she's measuring like 88 ohms. Which might be why the 6PQ5 tube we suspect was in this socket was kind of cooked. Was looking like it was cooked. So we're definitely going to replace this guy. Alright, and we have also stumbled across our first example, if you can see where the pointer is, of one of the cathode bypass caps. This is the resistor we were just talking about that's cooked. This yellow wire is also connected to that pin, tube socket pin, that this cathode bias resistor for this tube is connected to. And if we follow this wire back, it goes to the can capacitor. So we're not going to do this silliness. We're just going to piggyback a one of these guys to bypass it. So I'm going to replace these cans. I did measure them, and the cans were way off, just like everything else in here. And we're going to replace one of the cans, and it's going to cover all of the filtering, and then all of the cathode bypass caps will be these guys here, piggybacked onto the bias resistors. So yeah, that's what we're doing. Major surgery here, doing some transplantation. And for today's episode of Your Taste in Music Sucks, while we're working on this amplifier, we're listening to the 17-year-old blues Saraceno playing with Jack Bruce and Ginger Baker. It's a little different. Definitely blues Saraceno, definitely kicked up a notch, but yeah, Blues is an amazing player. He's one of my favorite guitar players, as you can tell. Yeah. Jeff Bezos just stopped by. I forgot to order these when I placed my order for all the parts for this with Antique Electronics. So these look pretty nice. Let's pop them open. Alright, so we have RCA, what do we call these, terminals? RCA binding posts for the inputs. And I think the amplifier chassis has 4 inputs on it. 3 or 4, maybe even 5. There's like a stereo and a mono, and it's got tape, record player, and tuner. But we just need inputs for a record player.
And here's a handy phono jack for plugging in your record changer attachment.
For the Tone Princess. And I'm going to get a Bluetooth receiver. And I don't know if I'm going to hardwire that or if we'll need an input for that. And then I'll probably put an extra one just for, you know, just to have the ability to plug something else in. Something unforeseen. And here are the banana plugs for the speaker wires. These are pretty sexy, huh? So, alright. Cranking away here, slow going. A lot of the resistors, it seems like I have to replace about 50% of the resistors. Either they're way out or they're spot on. So we're just checking them as we go. But we're just kind of methodically starting over here and just gonna go over to here. But so far so good. And that's what we got. We're about here. I'm looking at this guy right now. So alright. Back at it. Wait the bomb. Alright, I'm about to call it quits here for this session of building here. Got a lot of work done. Got most of the electrolytics changed out. And I think I understand why they did what they did with the 2 multi-section can caps and why they split the filtering up. Half on one, half on the other. The second filter cap, which is this guy here, because of its position, it was just in a better place to run the dropping resistors or the load resistors, you know, point to point from the tube socket over to here, rather than have to go all the way over there. And then the other thing is why they use multi-section can caps for 4 different bypass capacitors. You know, 20 microfarad capacitors back in the day would be big chunky things, and you know, so take 4 more of these and stuff them in there, you know, it's already kind of a bird's nest, and that would have complicated matters. So, you know, save space by using the can cap and running wires over to them. But we don't have that problem today because, you know, this is how big a 25 microfarad capacitor is. I didn't get 20s. It would have been more expensive, a lot more expensive. These are like, basically, price of those is
as low as $27.95 at your RCA Victor dealers.
Negligible. But just need to change out a couple more. Those are the coupling caps on the first preamp tubes. These guys over here, V1s, but they're not called V1, but first preamp tubes that the input signal hits. So next session we'll do those, and these wires, I'm gonna have to, this can cap isn't gonna exist anymore, but I'm gonna have a can cap over here, so I need to run these guys over to here, and I need to figure out what I'm gonna do with the load resistors, or the dropping resistors, whatever you want to call them. Probably put a terminal strip in there somewhere. But that will be for another section of work. Alright, we will see you in the next clip. Alright, we're back. It's Friday night after work, home from the day job. Just doing a couple of little things tonight. I'm installing the speaker wire sockets, the binding posts here, with my hand. Here it is. Right here. And that involves drilling a 1/4-inch hole and sticking this guy through, and you can see that black gasket. There's 2 pieces. Well, why don't I take it apart? Hang on. Alright, so there's the binding post, and this non-conductive rubber or plastic gasket goes through our 1/4-inch hole, and that is to isolate the binding post from the chassis. And yeah, pretty self-explanatory. Alright, doing that, and then I'm going to install the, well, I'm going to think about installing these. I need to go online and do some research on adding a Bluetooth receiver to this, and I need to figure out how I'm going to connect it to this. I don't know if I'll just, you know, plug it into RCA, or if I'll hardwire it or what, but we'll figure something out. Alright, we're back, and we're upside down. I'll fix that. Pardon me, where the fuck is Mr. Pointer? Oh, here we go. Alright, so we got all of our speaker binding posts connected to the chassis, and I was checking out the input section here where you plug in your phono or your record player, tuner, and tape. So that, can you read all that? Tape.
The RCA push-button tape recorder is fun to own. And because it's made by RCA, you get perfect tonal quality.
Tuner, and we're going to assume this bottom one is for the record player. And here's, these guys come out here, and they go into this big monster switch. And I had the multimeter hooked up, and it all seems to be working. See that? It's kind of neat how they have 2 lines here. So we're turned all the way anti-clockwise. We're on stereo. Click it once. Now we're using this line on top to go mono. Turn it again. Now we're on radio. And then finally we go to tape with the second line again. But I'm also looking here. We have the balance left and right, but it's a double knob, double pot thingy setup going on here. And this back one is for the reverberation unit. And did a little bit of research. I can't find anything on RCA reverberation units from back in the day.
New RCA reverberation sound system for concert hall realism.
But there's some on some Sansuis from the 70s, and it basically looks like it sends your signal out into the reverberation unit. Does a little bit of EQing, but it also sends it through a spring tank. So that must have sounded frickin' amazing. But, alright, here we are here. here. We have a plug here, and it goes out to the reverberation unit and then comes back in and plugs back into the radio. We're not going to be using that, so what I'm thinking is might make, if possible, make a like a volume knob for the bass channel, the third center bass channel, so you can blend in your subwoofer. Will I be successful? Probably not, but we're going to try it anyway. So that's where we're at. Checked out some Bluetooth receivers. They all either have RCA and stereo mini pin outs. So we'll add 2 sets of RCA jacks over here somewhere. Probably going to disconnect the tuner and the phono and replace it with, one for the record player and one for the Bluetooth thingy. We'll leave the tape one connected because there's a lot of connections here for our grounds and going to the switches and stuff. So we'll leave this guy connected. Who knows? Maybe we'll find an ancient RCA tape player and we'll be able to plug them into that plug. Looks like this thing here. Alright, blah blah blah. Back at it. Here we go. Stay tuned. Alright, we're slowly coming out of the fog here. And you gotta love the user manuals from back in the day. I mean, they gave you full parts lists. They gave you schematics. They gave you everything you need. Anyway, so this guy here says loudness. That's R35A, and then on the other channels, R35B. So if we look at our parts list, R35A and B. Loudness, right channel, loudness, left channel, push, pull, on, off switch. So that's this guy over here. That's R35. R38 is this guy in question here that we're trying to figure out what the heck he does. And I've only been able to find R38B. So I gotta search on here and find R38A. But yeah, that's this guy right here. R38A and B, reverberation, balance. I'm wondering if we just don't do anything with this thing, it'll be fine. So I think that's what I'm going to do for now, until we get this sucker up and running, see if we can't get it running, and hope that, if this thing's not plugged in, then we're good. Because I imagine the reverberation unit was something that didn't come standard with the console. Or we're going to go with that theory right now anyway. So we just have an extra plug here. And then if that's the case, we'll fire it up with some speakers, left and right, and then some kind of subwoofer setup. And then maybe we can use this to have a separate volume for the balance of the subwoofer. Alright, glad we got to the bottom of that. Alright, so now I'm going to add the RCA inputs over here, I think. Alright, we have 2 sets of RCA inputs plugged into the chassis here. They look pretty nice, right? And now we just want to make sure that they're isolated from the chassis. And good. Nice. Alright, moving on. Alright, I think we're done with the drill, at least for now. Have our speaker outputs here. Got left, right, and then the bass channel, center bass channel. We have our inputs over here, which we'll get to when we get to. So it's time to fire back up the soldering iron and finish up what we were doing in here. Got a couple more electrolytic caps to replace. Are they electrolytic? I don't know. A couple more capacitors to replace. And then some rewiring of the big can caps on the other side. Like I said, we're going to replace 2 can caps with 1 can cap for all the filtering. And then we're going to piggyback or put separate capacitors for the cathode bias caps. Instead of splitting them up between the 2 cans, we'll have discrete ones. So It would be nice if I had a miniaturization tool to shrink myself and get my hands into all these little tiny spaces, but I don't. But we will muddle our way through. While we're waiting for the soldering iron to warm up, this came in from China. Didn't take too long to get here, a couple weeks maybe. I believe this is PTFE tubing. And what we're going to use this for, see how I'm using the insulation from cloth covered wire to cover the leads of some of our components. In the future we're going to use this. I don't think we're going to use it in this amp because, you know, we already started with this method. But it'll be a lot more flexible in the future and it'll look nice. And, you know, a lot of the boutique amplifier manufacturers out there today use this stuff, and it's pretty sharp. So I will put a link, if I remember, I'll put a link in the description of where you can get this. And it's super cheap. This costs like $2 or something like that. Free shipping from China. Got here in a couple of weeks. And yeah, we'll give it a try on an upcoming amplifier build. Yeah, everything will be awesome. Alright, actually I changed my mind. We are going to use that new plastic clear tube on these guys here because it's just a, you know, a tight mess down there. So we'll try it out, see how it works. Alright, I believe I have all of the capacitors replaced, not including the filter caps and a few of the preamp tube cathode bias caps, but the bulk of the work is done. Yikes. If this looks like it's a pain in the balls, you would be correct. So the tone priest is going to have a little bite to eat, and then we'll be back at it, and I think we're going to attack the can caps. Yeah, that's what we're going to do. Alright, stay tuned for that. Okay, happy Sunday morning. We're working on the power supply here. Here is the first can cap. It has 235s and 220s. The 235 sections are being used in the power supply here. So we have C49A, C49B. And then the 220 microfarad sections are being used as cathode bias caps. So we have C49D on the center channel output tube. And then the left and right channels share a bias resistor and bypass cap. So like I said before, we're going to just only have one can, and then it's got 4 sections, so 2 sections will be the power sections of C49, and then the other can, originally C50, had 2 20 microfarad sections in the power supply, and that'll be the other 2 sections here. And then we're going to have all discrete cathode bias caps instead of going to cans. So that's what we're doing now. We'll get a bunch of chips in there and make sure those are all out before we fire her up. But yeah, she's coming along. And we've also replaced these 200 microfarad capacitors, filter caps that are in series. And that's these guys here. I wired it a little bit differently. I got a negative and a positive leg combined, and they're going to where it's supposed to go. Doing a little bit of changes, but it'll be effectively the same. The wire I'm using is pretty stiff, so if we don't, you know, batten this down to the chassis somehow, I think it'll be fine.
Let the children use one in their room.
You know, it's not like it's a guitar amp that's going to be banging around in the back of a van. But we'll think about that. But, you know, even if I don't lock this down to the chassis, I think it'll be fine. But more to come. Here's a quick little tip. Something that I didn't know, and you don't know what you don't know. So maybe a lot of other people don't know as well. Got a couple of resistors here. So 5W, 5 watt, 1K, 1000 ohm resistance. What's the J stand for? You'll see letters at the end of like capacitors as well. You'll see like, you know, 472J. The J is the tolerance rating. And if we look over here, if we can focus. Can we focus? There we go. Can sort of focus. You can figure it out. J is plus or minus 5%. And then one other thing I didn't know before back in the day, fuses. They also have letters on them and stuff. 3AG. I thought it was a 3 amp fuse. I didn't know what the G stood for. No, actually 3AG is actually the size. And that's the common size we use for these fuse holders. So there you go. You don't know what you don't know, but now you know.
Keep him flat and raise his legs. Now loosen his clothes and use a wet cloth. You got it.
Now we know.
And knowing's half the battle.
So for shits and giggles, I was testing the can cap here, the first can cap and second dropping resistor. It's supposed to be a 100 ohm, and this is spot on. But if we test the can cap, if we can read that, this is supposed to be a 20. Did we get it? Oh, hold on. Get on there. It's supposed to be a 20. This section's a 35. This is supposed to be a 35. Survey says 46. So it's interesting to me that this dropping resistor is still spot on after, what did I say, 62 years? Yeah, 62 years. But the can cap is, you know, toast. It's like double outside of tolerance or whatever. It's double the value is what it should be. So I don't think the console was run hard. I just think it was, you know, run a lot, like left on all day, every day. You know, the previous owner, original owner, was listening to NPR all day, every day. But whatever, for what it's worth. There you go. 0.035 nano. Ooh. Got the invisible nano cap. Happy Monday. I have today and tomorrow off from the day job, so I'm hoping to get a bunch done. Got the second can cap out. That was a pain in the butt. As you can see, I don't have a Snozzeramus, so, you know, this little guy isn't going to be able to melt that crap. So we had to get a little bit medieval on it. But she's out, and I put a little cover plate over the hole. So now we're just trying to figure out how we're going to wire all this crap in here. The A section was supplying the 235 volts for this guy here, center channel. What else are we doing? Oh yeah, up here too. It's basically everything to the right of that guy right there. And then the B section is supplying the 200 volts to the front end of your preamp focus. So all the plates for that, those two tubes. And section C and D were cathode bypass capacitors for V10 and V11. V10, A and B, V11, A and B. So that's, I'm not worried about that. That we can do. But, you know, we've got 2, 4, 6, 8 plate resistors, plate load resistors. We need to supply voltage to and then connect to the tube socket pins for all these tubes. So yeah, what a great idea I had by downsizing. But we'll figure it out. Where'd those thingies go? I don't know where they went, but we'll get some terminal strips in there. We'll figure it out and get it done. The MP3 receiver came in. Got some RCA cables. Everything fits. That's gonna go like that. Get your old phone, plug it into there, and then play some bitchin' Alice Cooper. So that's where we're at. And yeah, this sucks. This is a real pain in the gonads. Alright, so here's some real minutia here for any of you amp nuts out there. So we have our power supply, and, you know, gets rectified, dropped. So we got the first drop, second drop. That's this guy here and this guy there. And then because they were using two separate can caps, they didn't put the third drop, 3300, from this pole to this pole. They ran, how do I explain this? So we got this wire, the 265 volt, running out, going to where every place it's got to go. And then at the end of the line, here's your 3300 dropping resistor. And then it's going from there to where it's got to go, and that's this wire here that landed on the second can cap. So that's here on the other side of that resistor. It goes out to where it needs to go. Then it landed on the can cap, and that had a 10K from one pole to the other pole, from square to whatever that shape is. What do you want to call that? I call it a T because it's the letter T in Egyptian, so we'll call that T, square to T. What I think I'm going to do is take this guy out, put him over here, because it makes more sense, and then, you know, run the juice to where they need to go. It's probably be a lot easier. This would have been easier just to build this fucking thing from scratch. What did I do?
The situation calls for an expert, so Joe calls RCA Service Company. Skilled RCA service for fine RCA Victor television.
Actually, I changed my mind. Because if you can see, which you probably can't, juice comes in. What do we got here? 265 volts comes in. It's feeding a bunch of tubes, the power tubes. Then it gets dropped to the 235. Is that right? Yep, 235. And then this is feeding 2 plates of this tube. So I'm just going to not reinvent the wheel and wire it like they wired it. Hopefully we just need to tack onto this wire or replace this wire to make them long enough to go over to here. Hopefully this doesn't turn into a big ball of noise, but I think with this grounding bus that they're using, this ground scheme, should be okay. And again, this is the Fisher-Price, my first hi-fi tube amp for an aspiring hi-fi snob. So this is why we do this stuff, to learn. So when we do it for real, you know, we can hopefully know what we're talking about.
Here is a true electronic servant.
All right. Happy Tuesday. It's election day. I got a lot to say about that, but I won't because who needs that? Just a little quick update here. I think I got most of the stuff all wired up. Got the speaker binding post wired up. I'm wiring up the new RCA inputs to the selector switch here. And there was something I wanted to say, but I forget what it is. But when I think of it, I'll let you know. But getting there. Definitely getting there. Alright, I have identified a strange little quirk here. Running low on parts that I bought to replace for the amp here. And we have this 100 pico capacitor, which is this guy here, 100 microfarad. Alright, and as you can see, it comes off the cathode of the last preamp tube for the center channel. And it bypasses this 3.3K ohm resistor. Alright, so that stuff is right here. Here's our 3.3K ohm. Here's our capacitor. And it should be going from here to here, from one side of the resistor to the other, bypassing it. But it's actually going to the plate of the center channel power tube. So it's going from here to here, which is odd. And then the other thing is they use the stripe wire for positive instead of negative, so whatever, we can deal with that. So we have the blue wire here, which comes from your output transformer, going to the plate, and then from the plate to the positive lead of your speaker wire here is bridged with this capacitor here. So it comes out of here, and then this capacitor is going from here to here, which is a little odd. So yeah, this thing's got some issues. And then here you got the yellow wire also connected there, which yeah, see here, yellow. And then the blue striped wire would be this guy here. But yeah, so I think this is, hopefully that all makes sense. It's hard to keep all the errors all aligned in my brain, but I believe this was miswired from the factory.
Remember, the world's best names for quality. RCA.
You know, which might explain why one of the power tubes was looked like it had been cooked. So we'll go ahead and fix that. I don't have a 3.3K resistor. This guy's reading 3.6, which is, you know, technically within spec. I have a 3K in stock, so if I need to either order a new part or use the 3K. But we'll fix all this up. We'll get this guy out of here. He's probably seen better days, and we'll wire this correctly, or at least according to the schematic. We'll wire it that way, because the way they have it wired does not make any sense at all. All right.
Of course, when I build them, yes.
We are back again. It's Saturday night, and that's all right for fighting. Made it through the work week. This is what everybody's working for, right? All right, enough rock and roll cliches. I think we have all the components replaced, and the dog agrees. Tone Pep, that is. What I've done is I've checked every component at every node to make sure all the connections were correct. And as I methodically went along in the schematic, I used the orange highlighter to mark that that is confirmed. And yeah, she looks good. So now I think what we're going to do is we're going to grab some speakers, hook them up, plug her into the current limiter on the variac, and dial her up nice and slow and check some voltages, and hopefully, if everything works like it's supposed to, can crank some good old time rock and roll through this. Here we go. Alright, for testing purposes, I dug up a couple of these speakers that were kicking around the tone church here. Some nice crusty 70s era Panasonic speakers, model Rca Rs-189B, 6 watt, 16 ohm. The RCA is looking for 4 ohm, but this will be fine for our purposes of just seeing if this sucker works. Here's what the speakers look like. I think they're 6-inch.
She's as big as I am now. The Master 21.
But the enclosures themselves are kind of nice. Kind of like these. Can you see that? Probably not. Kind of like those. Maybe if we got some good drivers and stuck them in here, these would be pretty nice, because they're in real nice shape for their age.
Well, I just don't want you to get the idea that merely by adding a big speaker to an ordinary record player or radio, you get high fidelity.
But anyway, speaker wire was an RCA, so I just added, I think this is the power cord, the original power cord from this thing that I'm putting in there, because we added these, and that's not RCA, so yeah, we need bare wire ends to plug into there. And we're testing the continuity, 16 ohm speaker, 14.4 ohms measured. And now we just need to get the polarity. So let's see here. Connect onto the negative side. 14 ohms. Connected onto the positive side. 0 ohms. So this side is connected to positive. So this guy right here is negative, and we'll mark them with some black Sharpie, and we'll know which side is negative, which side is positive. Pretty simple stuff. All right, moving on.
Would you like to hear a sample? It'll make you feel as if you're really in the Grand Canyon. Now.
Green-eyed lady, passion's lady. Dressed in love.
How about that?
Perfect fidelity.
It's kind of quiet. This is all the way cranked. It's not very loud. 16 ohm speakers might have something to do with that. But I don't know. I think it should be a little louder than that. I'll grab some 4 ohm speakers, even if they are big, giant 12-inchers. That's what she said. And hook them up. And it seems like the left side is a little bit louder than the right side. That's probably tubes. But yeah, how about that? She works. Alright, before we get a copyright strike here. She's working. That's at 120 volts. We're pulling, what are we pulling? Here's the stats right here. 119 volts on the current limiter. 2/3 of an amp. 72 watts from the wall. Not bad. How about that? The Tone Priest is getting pretty good at this stuff. Alright, so we're going to do some tinkering around. We'll check voltages. We'll see, swap out some, see if we can find some 4-ohm speakers and see if that makes a difference on the old volume. But test voltages, all the usual stuff. Alright, hang tight. Here we go. Alright, so volume works. That's good. It's just not very loud. And these speakers are probably like, 25 dB sensitivity, 16 ohms, so that's probably choking that out. Bass works. Treble works. Stereo, mono. It all works. How about that? Good song, right? Anyway, second copyright strike. So upon further consideration, I think I'm going to end the video now. It's probably already 6 hours long. So what I'm going to do is I'm going to go to either Parts Direct or Crutchfield or something. We'll get some speakers for the Tone Princess. Some good, nice little bookshelf 4-ohm speakers, and some kind of subwoofer for the 2.1. And this is, the Fisher-Price, my first RCA tube amp. And the whole point of me getting this was, it was RCA and it was a good deal and the tubes alone were worth the price I paid. But it was to get my hands dirty doing some hi-fi stuff. So I'll get the speakers and then we'll do the tweaks, trying to, squeeze some volume out of it. I have some thoughts on why it might be so quiet, but... Tone Priest from the future here. One of the reasons why we were having such low volume is... I was using my old cell phone to drive the Bluetooth because I need this cell phone here to make the videos, but I disconnected the old cell phone and ran the Bluetooth off of the phone that's recording this video right now, and the volume was much louder to what I would expect. So there's part of the problem. So yeah, whatever. There you go. Bluetooth. Uh-oh, we got a little static. A little static. Just got some bugs. We'll figure it out in part 2. Alright, back to the past. Beyond what was already said, but, that will all be for part 2. So if you made it this far, thank you very much for watching my my movie. I hope you enjoyed it. I hope you learned something. I know I did. I learned a lot doing this. And, yeah, rock on, dudes and dudettes.
Okay, but when I push the button on the tape, you'll have to turn off the projector. Now.
Done!